Before we start talking about completing the square, here are a few things that we need to know so we can actually use this knowledge when we're completing the square. These two are called perfect squares. A plus b to the second power and a minus b to the second power. Well, they're both squares. They're called perfect squares. So if I'm talking about a plus b to the second power, I'm actually talking about a plus b times a plus b, right? So I'm taking a plus b twice, 1, 2. Same thing with a minus b to the second power. A times b times a times b. If you want to go a step further, using distributive property, a times a times b, this is what we end up with. Again, distributive property, this is what I end up with. Look at the patterns. What do you notice? Compare them. What do they have same? Remember, we need to notice things. Here, I use distributive property. First term, a times a times b times a, b times b. Here they are. And we know that a times b, we have it twice. So, of course, we have two a and b's. Only one a squared and only one b squared. Same thing down here. A times a times b times a, b times b. We have, again, only one a squared and only one b squared. And because it was negative times negative, we have positive. And we have negative ab times negative ab and negative ba, which is the same thing, commutative property. So we know that's negative 2ab. So this is perfect square, distributive property into trinomial. Remember, factoring is from trinomial into factoring to get our perfect square. Here's one more. Difference of squares. Difference of squares. So we have a difference of two squares, square A and square B. And this is exactly how they look like. A minus B times A plus B. That's it. And here we are factoring backwards from previous, backwards from distributive property. So we have trinomial, and we need to get trained in our eyes to recognize the first term is a square, last term is a square, and the only term in between those two squares is 2a times b. Here, the only difference is subtraction, but only here. Again, first square, second square, and the third term is 2 times first and second square. Or should I say 2 of a times b, 2 of a times b. So we have trinomial, we'll factor it. We have another trinomial, we'll factor it. Here it is. I know I have two squares. One is a, one is b. But the final one, when I factor it out, I have a plus b. So I have first and second square. But now I'm going to have a together of them. A plus b square. Huge square. Here, again, same thing. I see a square. I see b square. I have double in between. I have subtraction here. So it has to be a minus b square. So I have different square. But both of these have a and b. One is plus, one is minus. So this is same as factoring perfect square. You're just working backwards.